Hey, it's Harrison, and in today's video we're going to be making drywall from Selenite.
Alright, so this is all the Selenite that we got from Nevada. So yeah, as you can see, this Selenite it is white crystals, very delicate stuff. It's about a 2 on the Mohs hardness scale. It's not incredibly hard. As you can see, it's breaking and coming off on my fingers. I don't know if you can see that. Unlike the name suggests, selenite, this doesn't actually have selenium in it. So we're not going to be extracting the selenium out of this. We're going to be actually making this into drywall, because selenium is a kind of gypsum, and gypsum's used to make drywall. But I don't know if you can see it, the selenite, like other gypsum, is also accompanied by sulfur most of the time, and which is this kind of powdery white substance right there. Now, doesn't smell like sulfur. I have multiple pounds of sulfur and I know what sulfur smells like, so there's that. Now, sulfur doesn't make good drywall is the problem, so I'm going to need to get it out, and there's 2 ways I think I can do that with. One, I can burn it, which is not very economically friendly. I'll do that more of as a last resort. 2, I can try to melt it, which I think I'm going to do that. So I'm just going to get some pieces out of here that aren't like super good and high quality. That's a dirty piece right there. It's so good to have, I suppose. But just some, you know, pieces that like aren't that good. And I think I will smash these up. It's not going to be that hard. It's super delicate. It's not that hard to break. It's breaking in my hand even. So I'm going to break that up, and then from there I'm going to heat it up, try to get some of the sulfur out of it, and work from there.
I'd say that's crushed.
Alright, so now that I've crushed this stuff pretty good,
After I successfully got water out of the sample, I decided to get all the water out of the rest.
wait, well, I was going to say this is where the mad science begins, but the wind picked up. I can't really do this stuff when the wind picks up. Alright, so I got my dehydrated calcium sulfate, or not completely dehydrated, but I got my semi-dehydrated calcium sulfate. I have my finely ground calcium sulfate crystals to act as these, or gypsum crystals or selenite crystals to act as the accelerator for the curing process. I have a little bit of paper shavings to act as the fiber that I need for the thing. I have 2 sheets of cardstock that I'm going to put in the container, pour the layer on top of, and then put another thing on to act as the top and bottom. And I have some cornstarch to act as the fire retardant. And then I have some water to make it a slurry that I can pour. Alrighty, there we go. Got my scoopula out here. Alright, first of all, I'm probably going to want to throw in all these in the paper shavings. Now, this just acts as an accelerant, so this gives this finely ground gypsum gives the crystals something to grow on. So I'm probably just going to want to do 2. I'm not going to want to do an awful lot. I'm going to want to throw in my starch to act as fire retardant. Okay, I got my paper, I got my stuff. I think I'm going to add some water. Yeah, I'm gonna need more water. Oh. This is gonna be some crappy looking drywall. It's pretty much going to make a paste, like you see here. It's making a plaster. And if it does harden, and it does work, I don't want that plaster to be in a nice glass beaker. So I'm making it in a cup, so I can just toss the cup when I'm done. Alright. Just give this a good mix. Make sure everything's all together. I think I'd call it good. Alright, so then box. Paper in box. Paper is too large. Okay, very cool. That's the minor problem. I'm probably gonna add a little bit more water just to get it more soupy so I could like pour it into the box. Yeah, let's just do all of it. There we go. There we go. And now leaves a little bit more like a liquid, and it will take the form of what I poured in. Mostly, I mean, I can still move it around and stuff. It's still a paste, but it's a little bit more like concrete than drywall. But oh well. So yeah, let me just start. Holy cow, it's getting hard to move. It's getting difficult to move already. Maybe I put way too many crystals in and accelerated too. Look at that, I can snap this stuff already. This is gonna be the cruddiest drywall in the entire world. So I'm just pretty much press fitting the entirety of this. Holy cow, it's already almost a solid. So yeah, that's there's my drywall there. So just gonna wait for this to like finish hardening, do all that stuff, and then I'm gonna test out some of its properties. Alright, so here's my little drywall that I made. It's had several weeks to, well, dry out. So I'm going to get it on the mold and see what it looks like. Hey! It stayed together. Well, yeah, it's all together. I made drywall. That's good. That's good. Yeah. But the surface of it is not really perfectly flat. I don't know if you can really see that, but oh, this piece of paper fell off. The back part though that I pressed it against seems really good, but that's what the surface looks like. Now, it's not perfect, but it stays together. It's there. So I was able to manipulate the rock and make it in such a way that it stays together, which is a good sign. Alright, so I cut a piece of the commercial drywall out, so it's about the same size. Alright, there. So I'm going to go test these out and see how they do. The first test I'm going to do is a heat treating test. So I'm going to heat this side, and I'm going to measure the temperature on this side, and I'm pretty much going to see it after I heat it with a blowtorch for 30 seconds or a minute. How much does this side heat up compared to what its original temperature was? And I'm gonna see how they perform. Alright, so here I have a blowtorch that I'm going to light, and then I'm going to sit here. I'm going to start heating the side that has the paper off, just because the paper is going to burn, obviously, and it doesn't actually give the drywall any of the properties other than staying together. So I'm going to heat this for 30 seconds, and then I'm going to measure with an infrared thermometer the temperature on the opposite side. So right now it's 58.6 degrees. Just keep it there for a while, make sure I got a good temperature. Yeah, 58.6 degrees, and then I'll see about what the temperature is after I hold it there for 30 seconds. We're going to start off with the commercial grade drywall and then move on to mine. I'm going to just pick this up and move it, and then put the other one next on after I measure how much it's done, because I want to make sure that the blowtorch has the same kind of heat coming through it. So I'm just going to make sure that as many properties from the last experiment are the same when I do this one. Shut up, cat! There we go. Let's do that. Alright, one. Alright, there's 30 seconds right there. 73 degrees. Alright, now let's do mine. Make sure mine's the same temperature. 73. Oh, there's a little bit of fire happening. Not sure if you can see that. Ah, because I started on the paper side like an idiot. Cool. Yeah. How did I not notice that?
Alright, there's 30 seconds, I think. Measure it.
73.7. Alright. Alright, so yeah. So there's the two. Yep. No, granted. This side, I did do the paper side on, so that was a little bit of a mistake. But, like I said, the paper's just for the structural integrity, more or less, of holding it together, making sure it doesn't get all those little crumbs everywhere. Even now, holding this, I can touch the back side of this even though it's only been 30 seconds. That's what that side looks like. Let's compare it to this. So that's what the two look like. Yeah, I can tell you that this one's a lot hotter holding it in my hands, but it's also had less time to cool off. But yeah. Alright, so if you were to ask me if I was successful with this experiment, I would say, yeah. I would say it is very successful. I was able to make drywall out of the rock that I found in Nevada desert. So that's pretty neat to me. I mean, yeah, they didn't, my drywall did not perform as well as the commercial drywall. This, when it was heated with the blowtorch for 30 seconds, changed with 14.4 degrees Fahrenheit, that is. And this one changed 15.1 degrees Fahrenheit. But still, that's only a 0.7 degree difference between the two. It's not even a full degree. So it's still insulated just about the same. And that's pretty neat to me that I was able to replicate this stuff. Now, granted, this stuff is not nearly as strong as this stuff. I could probably break this a lot easier than I could break this. But yeah, I was able to make this nice rock in the drywall. Boom, science. Thank you all for watching, and I'll see you all in my next video.